Those of you who don't know me, I guess most of you don't. My name is Sean. I'm a principal product manager, product unit manager actually, from Huawei. And you're going to stick with me for some time this afternoon. And I'll tell you something about our AI stuff, on-device AI stuff. And hopefully towards the second half of the session, I will actually do some real-time coding. And hopefully the demo guy is with me and that can work. If that doesn't work, I also have a backup plan, play some videos. But I really hope it will work. And so first off, let's do some poll. Who of you guys are developers here? Please raise your hand. OK. I see like 45%. So who of you guys are not developers? Man, this works every time. You see, this really works every time. You ask a room full of audience, well, it's not full here because it's such a big room. You ask them, like, who are the developers? Some of you guys raise your hand, and then you ask who are not developers, and the other half didn't. So that means we have some guys here in this room that's not in a binary state. It's in the middle. You guys who didn't raise your hand, in both of the times, you're not developers, at the same time are developers. So who are you? So let's try it again. Huh? So who are not developers here? I see one girl. I know her. So 3 guys, 4, 5. OK, the camera guys. Who are developers? I think we're reaching like 97%. I still think there are 1 or 2 or 3 guys who didn't raise his hand at both times. But anyways, just a quick info here. This is called, in a behavioral economy, it's called the default option phenomena, which means that most people stick with the default option because default option here is not raising your hand. Now, surprisingly, this also fits the description of physics, because in physics, there's this law called lower energy state. Everything in the universe tries to stay at the lower energy. And here, in this case, not raising your hand is saving energy. As you can see, all these laws in physics and economies, it just works together in this situation. It's really amazing. Every time I try this, every time it works. But anyhow, let's get started. So I'm here to talk about like our AI stuff. So like I said, 2 sessions. Let's just get started with the first session. So you probably have been through some of our talks, or at least some intros or something on our stage. So basically, one of the major features of the new Huawei devices coming from last year, end of last year and this year, namely the P20 series and the Mate 10 series, we actually put a chip on our phone. That chip is called NPU. NPU stands for Neural Processing Unit, which means that that chip processes neural network on the device without any help of the cloud. And this means that you can put a lot of AI stuff now on the device for 2 reasons. Number 1 is that it's faster and more power efficient because now you don't have to send a bunch of stuff into the cloud. This actually is very useful in some scenarios like the Prisma guys who's going to come later on the stage to talk about their stuff. Imagine you have to send a big picture into the cloud to do the inference, then come back. That takes time because network is not always stable. So that's the first reason. It's performant yet power saving. It performs much faster. I can show you some metrics later. It performs much faster, but uses much less energy than the CPU. And the second reason being that sometimes you have to really think about the privacy of your users. And sometimes the stuff they give you, they do not necessarily want to share with the rest of the world. Meaning that you want to process these stuff on your device without having to connect to the network, without having to send it to the cloud. So for these 2 reasons, you want to use the on-device AI. And maybe there are some other reasons as well, but I think these are basically 2 of the major reasons. Now, we have seen some trend in the past couple of years. Actually, namely this year and last year, AI stuff are coming to the device. Now, I have actually collected these couple of articles, and they're from 3 Jeffs from different companies. But apparently, after the fact, it seems like successful guys tend to name themselves Jeff. So if you want to be more successful, maybe you should thinking about changing your name to Jeff. But anyhow, the first Jeff from Apple says that the smartphone will get even smarter with on-device machine learning. Of course, Apple has their agenda because they're not particularly strong on the cloud, so they want everything to be on device. But anyhow, I think this is true, though. The second Jeff from Qualcomm said that on-device processing and AI goes hand in hand. Of course, if a lot of AIs are moving on the device, then you do more processing on the device, which is good for their business because they're Qualcomm, they make chips, right? And the third guy, Google, Jeff Dean. I think most people should be familiar with Jeff Dean, or at least know about this guy. He's an amazing guy. He said 80% of smartphones will have on-device AI capabilities by 2022, which I think is going to be true. We'll see. I mean, it's 2018, so there's 4 years more to go. But anyhow, as you can see, there are this trend that AI processing or AI inferencing, for that matter, is going more and more towards the device, right? So that's the trend there. Now, let's talk about our NPU. As you can see here, we have some benchmarks. This is done by our own lab. But in all fairness, we have 25 times more performance than if you would do the same thing on the CPU in terms of doing the AI inferencing with neural networks. And yet, it's power efficient, 50 times more power efficient than the CPU. And if you want to talk about the specific numbers, here's some benchmark we did with ResNet 50. We can do 2005 image inference per minute, while if you do that on the iPhone, particularly iPhone X, you can do like 880 per minute. And then, everything from there goes down the hill. And if you do it with the Galaxy S7, S8, I don't think they have GPUs, but I could be wrong. But anyhow, it does 95. So you can see the comparison there. And these are other networks that we did benchmarks on. But anyhow, I want to actually have another quick poll. Don't worry, it's not a trap anymore. So who of you guys are at least familiar with AI or machine learning and know the basic concepts? And you know about ResNets, and 50s and 120s and inceptions and VGG networks. So some of you guys know. But anyhow, so for those of you who don't know, these are just different AI models. They're mostly trained for image recognition. They have different architectures and have different depths, if you will. If you compare like ResNet 50 to ResNet 152, it just basically how complex they are, 50 versus 152, if it's under the same name, like ResNet here. But anyhow, it's just different AI models that can do the image inference. And of course, the amount of computation in that model are different. So here are some benchmarks for these models. But if you go down to the basics, why that NPU is faster than GPU and then CPU is because, our traditional architecture on CPU, if you think of it as a table, a lot of unit or a lot of surface areas are occupied by the control unit. That is what CPU is good at. It's good at logic controls. And it has a lot of units that does the computation, arithmetic computation, but it's probably like 50%, 60% of the size is being used for that. But if you move onto GPU, it has a lot more computation unit. It has a lot less controlling unit. It's because GPU is traditionally, good at processing image, and a lot of times you can process image in parallel, and that's why GPU is good at processing actually vectors, basically. So now the NPU is good at or designed to process tensors, which means that tensors being the multi-dimensional matrix or arrays, if you will. So that's why NPU is faster, because it's just good at processing these multi-dimensional arrays, or we call them tensor, which is the building blocks or cornerstone of the neural networks, which is basically, if you will, the neural network equals to deep learning, which is where the AI has been advancing in the past couple of years really quickly. So that's why we can directly process tensors, and in that way a lot faster than GPU than CPU. So that's the secret of it being faster than GPU and CPU, hence the metrics before. So that's a little bit why. Since a lot of you guys here don't, my slide is stuck. I don't know why. Okay, now it works. This is probably why I left Microsoft, because sometimes Windows just gives you all these problems, and a restart would work, but I don't want to restart my computer here. I kind of want to skip these slides because this is a little bit more like details, since a lot of you guys don't know a lot about AIs here. But this slide basically says that how we actually run the model. We don't actually load the model and then compile on the fly, like jet compiler, whatnot, and run it. We actually compile to machine code and directly run it. Hence, we can run it faster, but that also means that we will have this like preparing step where you actually have to convert your model, like your model from TensorFlow or Caffe into our format or our machine code. So there's this little step needed. But don't worry, we'll talk about that later with our demos, and in our tool, we will show you how you can easily do that with just a drag and drop. Now, talking about neural networks, you have to know that it's basically a cluster of computations. And in that cluster of computations, you have basically different layers. It's just like our neurons, you have layers. And in these layers, you have different operators to take care of different kind of computations, convolutions and whatnot, concat and whatnot. But we have a comprehensive list here tells you that these are the neural network operators that we support at the moment. Notice the at moment, because we're going to add more support gradually, even though this is already the biggest list on the market today. If you look at CoreML supported operators, CoreML being the Apple's on-device AI framework, they support 60-some operators, and Android NN from Google supports, I think, 30-some operators. So we have a pretty comprehensive list here. Now, you might ask, like, what if I don't have something that's not on this list? What if I train a model that's a little bit more complex than you have thought, and it has like operators not on the list? That's okay, because we will have tools to support that. Again, we can demo that later. But just to wrap it up, it's faster, it saves energy, and we support a lot of different frameworks, and a lot of neural network operators are already supported, but we're adding more support. Last but not least, the integration part, the part where you are actually going to get down to the business, you're going to get your hands dirty to integrate your own model. We'll have tooling support, which makes it much, much easier. And we will actually show that later in the demo. I'll do some coding if the demo guy is with me. But anyhow, we just want to share a little bit how the Prisma guys did it. For those who don't know about Prisma, they are a wonderful app. I think this is the first AI-capable app I have ever remembered in the market. I think it was a couple of years ago. you guys first published on the iPhone, and they can do this style transfers. Basically, you take a picture, then it transfers to entire different style, like impressionist, and what you have. Basically, make the photo really look stunning in a special way. But anyhow, they use AI, and now their AI processing is on the device, our mobile phones, and our friend from Prisma will just tell you a little bit about how they did it from a developer perspective, what kind of do's and don'ts and what kind of stuff you have to be careful about. Then after that, I'm actually going to show a real demo on my device and actually show how you could do such an app with our framework support and with our tooling support. So without further ado.
Is it working? Oh, good. Thanks, Sean, for introduction. Let me get a little introduction about myself. My name is Maxim. I am developer in Prisma, and I'm doing research on how accelerate AI on Android phones. And I'm working in Prisma. Prisma is a company that doing AI photo improvement, and we got B2C and B2B direction. On B2C, this is this application. So. On B2B, we provide SDKs and technologies to use on Android device, such as style transfer, segmentation, and single recognition that helps you to use semantic information from image to improve it. So we got on Android platform some awards from Google, maybe no, maybe not. So we used DDK on Prisma, and logically it contains on one single library that provides GenAI layer. And for this and so on, I will provide some code listenings to just understand what comes from Java side and what we need to perform some operations. So this model logically contains initialization phase and processing phase. Installation phase maintains of HiAI manager and HiAI environment, such as model initialization, model loading, and unloading to keep memory in consistent state. So as you can see, for loading, we just need, for example, for loading from assets, asset manager, and just a model name. On unloading, we just need model name. And so if model manager is not initialized anymore, or maybe don't from first start, we just create it. So processing phase itself contains some 3 steps. It's just pre-processing data, doing forward inference itself, and post-processing. We just need a float array buffer that contains image information and such things as width, height, and that's all. We are accelerated style transfer, so we just need to know input width and height as is just image-to-image transformation. So on pre-processing and on post-processing, there is one thing to think about it. So on Android native format is interleaved on Android bitmap, for example. So, for example, RGBA 8888 contains pixels in layout like RGBA, and something like that. And HiAI works on planar planar memory layout. So you got for first values for R channel, then for G channel, and so on. So we need to transform this and maybe applying mean normalization for this. We used Intel MKL for parallel processing of this, but you can use any arbitrary parallel processing library such as OpenMP that includes it on Android. This doesn't matter. So post-processing is just the same thing, but vice versa. You convert from planar channels that are output of HiAI and to interleaved fashion to display that and convert to bitmap to do everything you want. Forward difference is just contains of initialization buffer step initialization tensors. So we allocate tensors and copy from input float buffer to this tensor via mem copy and just run it, and that's all. So we use the style transfer models for our acceleration, and I got some tips for tuning. For example, convolutions does really great, so even compared with iPhone. But to reduce chance to be bound by memory bandwidth and do not make some bottleneck on memory, there is a requirement or tip to reduce scoping operations. And about upsampling, this upsampling layer is absent in Coffee, but you can use fork of Coffee that contains interp layer that do the same, or emulate upsampling via deconvolution. That's what you want. So we tested a 800x800 style transfer model on Huawei Mate 10 Pro, and we take a style transfer model that we run on CPU about a second and just try to run this model on NPU, and already got a X2 speed up. So this, after some model tuning, we increase the speed up to 3 times. So this model performs about 300 milliseconds compared to 1 second on CPU version. So a quick results of this, we got our model runs on our Prisma application. It's about 3 times faster on Huawei devices that supports TDK, and it was pretty easy to integrate. It's pretty easy and to use API provided by Huawei and DDK, and so. And you can anytime contact Huawei to support this, and we will answer. So, thank you, Sean.
Thanks. So as we can see, it will take some time to integrate your AI models into the app, but that was actually last year because these guys started early and they didn't have much of tooling support. But now it's a lot better situation. We have tooling support. We do a lot of stuff automatically for you, so you can actually just focus on your business logic, writing your app's logic, rather than focusing on, oh, how do I do this? How do I, how do I actually integrate a model? Why have a model? So right now, I'm actually going to talk to you about some of these tooling support we have. Then we'll see a demo. But before that, I just want to show you this. And if you look at the right side, or actually left side, this was 8:30 at night. I took a picture. It's somewhere South China, Shenzhen, next to Hong Kong. As you can see, a lot of things are overexposed. That's a typical situation. Like you go out at night, you want to take some good pictures, you take out your phone, doesn't matter if it's iPhone or iPhone X, doesn't matter, it's Android phone, the highest you can get from Samsung, the S9, I believe, or S9 Plus. You see this kind of situation. You're like, what can I do? You can do nothing. But at the same time, exactly the same time, I took that picture with my Huawei P20 Pro. As you can see, it's a lot better. A lot of things are not overexposed. This is not just a single shot with the camera. It actually uses the camera to take multiple shots and using AI to determine how to stitch them together under different exposures so that the right things are exposed with the right amount of exposure. And then you have this kind of photo where things just how they're supposed to look like. Maybe a little bit more enhanced than your naked eye, but it's certainly better than the ones that actually has a lot of overexposure. This is the kind of one of the examples how we put AI together onto our devices to make basically the user experience better. You could think a lot of different scenarios, different cases. You can use AI to improve your own app's experience, improve your user experience. This is just one of the examples. Now, you have probably heard something from us yesterday, how we have all these amazing APIs. that's basically with AI trained model behind it, or today how you can actually integrate your own AI models into our apps on our platform. And you probably think, oh, this is cool. I mean, I almost used S word, but anyhow, and it is recorded. So, oh, this is cool. But how do I use it, right? Because you always hear about these amazing stuff, but when you get down to the business, when you want to get your hands dirty, you feel like helpless because it's great promise, but you cannot implement it. So you're probably, your inner self is probably like this now, like, oh, this stuff is great, but where are the tools? How do I use it? Where is documentation, samples, and oh, you talk about AI models. How do I convert my own model from TensorFlow and Caffe or any other framework onto your platform? And oh, you talk about operators, but what operators are supported, what are not, and what are the the things that I should pay attention to, or even better, can you tell me like if my model just works or not, or if it doesn't work? How can I improve it? How can I fix it? So these are the kind of things we do with our tooling support. Basically, we call it IDE, but what actually it is it's Android Studio plugin, because we've done a study. We figured that everybody is using Android Studio to develop Android apps now, and we shouldn't build yet another, IDEs or whatever the stuff is. We should just, stand on the shoulder of the giant. Basically, then we build this a plugin on top of Android Studio. We're going to continue putting a lot more other developer tooling support into this tool, so that not only AI and many other aspects or the platform aspects of Huawei Mobile, you can use that with our tool, and hopefully that will make your developer life a lot easier. So, like I said, it's Android Studio plugin, and it's supported both on Mac and on Windows, because again, we did a study. We figured that even though you guys are Android developers, you don't feel ashamed to use Macs, right? I see Macs here and there. But, I mean, we just want to use the best tooling. So we supported Android, supported macOS, supported Windows, and most of UI stuff is drag and drop. So you just do this drag and drop and then fix a few things here and there, mostly because there are this one last mile where business logic should work with the code, and we have no way of guessing or inferring that. It doesn't matter what kind of AI we have. So you still have to do the one last mile, but a lot of things are done automatically for you behind the scenes. And we also have a lab. I believe we deployed quite some machines here in Europe lab, so that you can use our IDE to remotely connect to our device from the cloud, as if you're just you're just working with it on your desktop, and you can also remote ADB into that, basically pushing your app into that device and debug remotely. And we also have this HiKey 970 board, which is basically an embedded device. So it runs Android and other flavors of Linux as well. So you can use that to develop your solutions for embedded scenarios. And we also support that with our IDE. Basically, once you plug it in, and we'll just install the drivers for you, automatically connect that and project the screen onto your desktop and everything. So when we talk about models, like I said, the AI Foundation basically needs your model to work, because you know your business logic better, you know your scenarios better, you probably have the kind of data a generic AI model trainer or AI team doesn't have, so you want to train your own model. But once you have that AI model of yourself, you're going to want to import that onto into your APK and onto our platform, and we have that as well. Basically, it's still a drag and drop experience. When your model is supported, everything goes through smoothly. We basically put in all the SO libraries and C++ code and JNI encapsulations and Java API references for you automatically, so that at the end of the day, you just need one line of code to reference your model to do the inference, or prediction, if you will. And if your model had some of the compatibility issues, like I said earlier, if you use some of operators we don't support at the moment, it will actually tell you that, oh, here is your model. It has this and this layers, and these are supported, these are not. And for these are not, why they're not supported here, might be the suggestion that you want to, how you want to replace that layer and do the range training and come back to integrate it. And we also have this, it's very primitive, but still we are trying to build that within the next couple of months, basically AI model store where we share more AI models with the community, and basically you can use that as well. If you don't have your own model, but still you want to try the shared model. Because there are basically three things. We have our own APIs, which is the AI Engine. These are the models that we train ourselves. We just encapsulate that into the API. Then you can basically directly use that if that fits your needs. If you already have some AI model, or if you have some very specific particular business scenarios you can address the best with your own AI models, then you train that model and you can use our foundation layer to import that into the app and have that working. And the third way would be that try to figure out if there's shared model out there in the community, and you can also use that. So this is one of the, this is the third way, basically using the AI model store. So the entire process of how you work with these, of course, starts from downloading something. I mean, it always starts from there. You download our plugin and install it, and then here's the part where you decide whether you have your own model or whether you want to use our own API. So if you want to use our API, you go the top route. Basically, you use our tool for the engines, HiAI engine tools. Basically, then you just drag and drop some of the APIs we have. Or otherwise, if you have your own model, you use the tool like at the bottom to integrate. And then once you have coded up your app, you have that APK, you might want to test it. The way you test, of course, is using a real device. There's no better than a real device. And you use one of the HUAWEI devices, but you can use also the remote devices we provided for free, as long as you register yourself there, and you can get it for free, and you can do the testing over there through the remote devices. So that's another way. If you're working with the HiKey 970, which also has AI capabilities, you can also use our tool to connect to that and try to test and debug it. And once you've gone through that, you still need some testing, of course. We also have a comprehensive testing service in our lab. I believe it's starting to be offered in Europe, where you can do performance testing and functional testing. And if you do games, there are very specific gaming testing and a lot of different testings. So you can do that. And when you finish that, you can publish your app into our app gallery. So basically, that's end-to-end, walkthrough of how you would use our toolings. And like I said, if you use the engine part, which is basically using our AI APIs, you can just directly do drag and drop, and hopefully you can be done within like under an hour, from half an hour to an hour, and then integrate that into your app. So again, we do a lot of things automatically. So you just have to find the right API here and drag and drop to your code lines or between your code lines. And we do actually three things for you automatically. So first off, if you look at the middle piece, the code would be actually generated in the place you drop that API icon in. And second thing is that if you look at the top, whenever you use some APIs, you have to do the imports, right? But in this case, we actually automatically put the import code there on the top, so you don't have to move your fingers above. And the third thing is that our solution is basically AR package-based solution, which means that you actually have to write this one line of code in the Gradle script to import that AR and sync it. But we do that automatically for you as well, so that you only have to drag and drop, then all these three things will be there. Of course, at this point, Android will ask you if you want to synchronize the Gradle packages. You just click yes, and the package will be automatically downloaded for you. Now, you might be wondering where's the documentation, right? Because always when you look at the API itself is not enough. And we have documentation there. It's just within the tool, within the IDE. You click that API, you'll see, okay, here's the documentation. Here is actually what's the input, basically. In this case, it's API. I think we demoed yesterday, basically tells you trained with a lot of pictures, by the way, tell you how beautiful, if you will, this picture is. Not the content in the not in the content in the image, but the overall settings and lightings and everything. So in this case, if you look at the right side, the documentation is actually telling you its input is image, output is some float scores from 0 to 100. And then there's a sample code down there. You can also drag and drop these guys to the corresponding places. So this is how you would integrate an AI API, or AI Engine API, if you will. And now, the foundation part is basically the part I talked about where you have to integrate your models into the app. Still, it's a drag and drop experience. And we do the model analysis for you first. If the layers or the operators in your model basically are compatible with what we support, with everything on that list I showed you earlier, then you will be able to convert the model and integrate it into the right places. But in case you have some operators that you have that's not on the compatibility list, we'll actually show you a report says, okay, here's the list of the layers or operators you have, and these are the ones that's not supported. That's how you use the foundation tool to integrate your model. This is the report, basically. Again, I'll show you later in the real demo. And this is the remote device part where you can directly access from within our plugin on Android Studio. You just have to click the connect part, and then you will be shown with a login page. You log in there, and then you can basically remote access these devices. You can interact with them just like an emulator. And you can also click the debug button there up on the right side on Android Studio. Now your ADB device list will have one more device, which is this guy. We connect this to remote ADB so that you can actually push your app and debug it remotely. And this is the AI model store I told you about. But I'm not going to go more details on that. So now I'm going to show you a little demo and show you how I actually use our stuff to code it. So the demo here is simple, but not very simple. But so here's what I want to do. I want to be able to just type in a name. And then I want to find this guy. Basically, I use Bill Gates as example. I want to find Bill Gates, how old he is. I want to get a picture of his. Because I want to do this. I want to get that picture and use one of the model that's shared by the community. It's called AgeNet. This AI model can determine from a picture how old a person is in that picture. Basically, it'll give you a age range. So then they can compare that inference from that AI model with the real age of Bill Gates and see if my prediction is close. Then I'm gonna, because normally on the search engine, these would be the kind of pictures that's shown at the thumbnail size. So they're actually relatively lower resolution, and then I can use our AI Engine API to blow it up to make it clearer, which is the part at the bottom if you look at, and that would need one of our API to basically do, and so I can use that. So basically, I used our foundation, my own trained model. I also used our AI Engine API. So that's the purpose of it. Of course, I use a search engine to basically search the name plus age, then I get the result on the right side, and I use the app to put the image and the text in and do the rest. So I'm just going to show you how this app works and show how you can use our API to do that. Oh, by the way, we have this wonderful app that's companion for our devices. It's called HiSuite. I believe there is English version, international version. So all you have to do is basically install this guy and plug in your Huawei device. It actually projects the screen of the device onto your desktop. So I don't need all these. If you remember yesterday, there was this kind of projection light and a camera on it. So this is basically what's happening on my screen. So I can pull up this app I said, and I already used it, so Bill Gates is here. I don't know if you can see the difference or not, but the picture at the bottom is enhanced, so it's clearer than the one on the top. I can see that on my phone, but I don't know at this resolution on the projector if you can see it or not. But those of you who don't believe me, you can come here to see it later. So let me try something else, or somebody else. I might want to try Elon Musk. Let's hope the Wi-Fi works. Yeah, I haven't really adopted to Google yet, so it's using another search engine, so it takes some time to get the image from there. And, but anyhow, here you can see that the actual age of Elon Musk is 46. Here from this picture, from this particular picture, we use our AI model, the AgeNet, to infer that this picture, this guy in the picture looks like he's between 25 and 32 with 90.46% of probability. And it's mostly because two things. Those pictures you get from search engine, they're not necessarily the picture from this year. They could be from before. So there will be some error margins there. Another thing is that, in case you don't know, a guy like Elon Musk, he has his own stylist. So, you know, he might look younger with all the work that has been done by the stylist on him. So maybe let me just go back to Bill Gates. I say go. Again, network latencies. Yeah, it's a bit better with Bill Gates. His actual age is 62, and this one infers that he's between 48 and 55, with relatively high probability, 80-some%. And yeah, that's basically what the app does. So right now I'm going to show you how we can code such an app. Of course, I'm not going to start from scratch, in that I have some basics like the UI and my placeholders and the buttons and whatnot. I just want to show you the part how we integrate the model, my own AgeNet AI model, and how we use that HiAI Engine API to basically enhance the image. So now I have this model already downloaded on my disk here. This guy, it's a cafe model. Now all I have to do, I just try to do it again. So once you install our plugin, you will see it here. DevEco, that's our tooling branding. We're still working through the brandings. And now you see the engine part, like I said, the HiAI Engine part is the part you directly use an API from us. There are, of course, trained AI models behind it. And then there's this HiAI Foundation, which the part I talked earlier, where you use your own model. Now, then like I said, it's a drag and draw experience. If you just drag your model here, it will know it's a cafe model, hence configure the rest of the options, especially this guy, because if you know about cafe framework, it produces two things. One is the model, the other one is a description file of the model, basically this proto text file. But anyhow, we infer that because it's in the same folder. Like I said, we try to do as much stuff as we can automatically for you, so you don't have to bother with all these details. And it will put basically the assets in this folder, and it will generate such a Java API. It's called AgeNet model.java. It's because my model file is named AgeNet. It will just basically call the Java API your file name, then model.java. Of course, we will remove all these underscores and whatnot. Then you can later directly use AgeNet model.predict to load your model and use that to do the inference. So now I will click the run to start. We have a Docker container behind it that actually does the conversion. But like I said, we first analyze the model to see if it's compatible or not. I can show later a case when it's not compatible, what you will see. Then we do the conversion. Then we actually basically take all these results and put that into your project. I just want to show the details because it's kind of daunting if you would do it manually, because there are a lot of stuff behind the scene we put in here. These SO packages, we support both the V8A and V7A architecture, and also this binary, the machine code from the model here. It's all in your project in these places. You can inspect them later if you want. And it's a C++ based solution, so there will be some C++ code. But we encapsulate that automatically for you with JNI, so you get this Java level API you can directly use. But in case you want to mess around, or you actually wanna do some more stuff on the C++ layer because it's more efficient, you can do it here. And actually, quite some code our friend from Prisma has shown you later is actually in the C++ layer. You can also do that freely. So we put all these stuff in the right places. So in the end, all you have to do in your activity, here I have a main activity, all you have to do is one thing. Basically, you say at the right place, here, basically. So here I'm actually loading the, if you remember, I'm actually loading the image above. Oh, I'll just use a slide here. So I'm actually loading this image into my memory and convert that into pixels and give my API, then give it to the model to do the inference and get back the age range and probability. So I'm actually getting these pixels from that image. And before, I also have some code to go to the search engine to do the searching part to find the right text, basically the age, and also get the image from the HTML and basically put it into my memory and convert that into pixels. And then I can use my model here, or rather using the Java API here to do the prediction. So I want to predict on these pixels. So I get a result here from the inference of the model. The reason why there is red wigglies is because I actually did more stuff in the C++ layer, but I can do that later. But just before that, now you need to actually load this model. So you have to do this, basically. You use the AgeNet model.load and basically load the model into the memory when you run it. And you give it the asset manager because it needs asset manager to actually find the model and load it. And then at the right place, you use it to do the inference. But then just to be a responsible citizen of the community, you want to unload it. You want to basically not to burn the memory of your user. You would actually write this line of code on destroy of your activity here. You basically want to say AgeNet model.unload to unload it from the memory. So that's using the model part. You have to do model.predict, then the input. Here I have to fix actually some small things. I'm not going to go through the details here with these fixings, but I actually did have some C++ code to make this work better. Because then I changed the method signature here. And this guy returns a string array, but I want a float array, is because then I change my C++ code. Now it actually returns a float array. But then, those of you who know about the GenAI encapsulations, you also have to do it here, just so that the GenAI encapsulation is having the corresponding signature. Now this guy won't complain anymore, and this guy won't complain either. But then we still have the bottom part where I actually want to enhance the image, and that would be something else we can use, because now we have just integrated our model, and that one, like I said, I want to use our APIs. We have a lot of, I think, right now should be 20-some APIs in here. So some of them are, you know, like something about face. You can do like, for example, these face comparisons, you can compare the similarity of two faces, and face detection, you can find faces from images, and also other stuff like the one I told you before. Here's documentation. So here's how you use it. You click an API, you see that, okay, here is the documentation, and here's a sort of image telling you what is the input. Here it's input is image, and output is some score telling you how beautiful this image is. Then there's this code samples. Again, these guys you can drag and drop them. So basically, then I want to find this one enhances the image. It's called image super resolution, this one. I'm just going to use it directly here. So again, it's drag and drop. I need to find the right place. Basically here, I have the, actually I should have removed these code because I'm going to do it now. So I have the image in the memory. Now I have to do the enhancement part. So I'll just directly drag and drop this guy here. This is the part the Gradle asked me if I want to download the package. I will say yes. Now I'll just hide this guy here. Now this is a couple of lines of code I have dragged and dropped here. Of course, like I said, I have to fix a few things because these are sample code. Now, this is the initialization of our API. So most of our APIs always have this initialization part and referencing part and the destroy part. And you might want to put them into the right places. For example, this one here, initialization, I would actually put it on top with the onCrate of my activity here. Like I said, should have removed them. So basically, it's this part. I'll just put it here. Then there's also this removing from the memory part, the destroy. I'll just put it on the onDestroy method, like I said here. Of course, I have to fix a few things. This context looks right. And then here's the body of API. Basically, this API just initializes itself, then it needs a bitmap as input, some parameters, and you do the super resolution from that bitmap that's being loaded into a frame. Then it returns, of course, another bitmap, which is the enhanced one. So this needed some fix, and because this is another thread, it's not the main thread, so I have to do the proper context main activity dot this rather than this because it's a different thread. And I have already loaded bitmap into the memory, so I wouldn't need this. I just need that because I have already declared a bitmap and load that with the original image. And then this is the return bitmap, that's enhanced one. Clearly I want to make the naming a little bit clearer, so I do that. So now I return them and show them on the UI. And let's see if it compiles. There's some problem here. Never seen this one. What's this? Let me connect it a bit. Normally it's a network dies on me, but now it's something else. Config. Program type. Anybody knows why? Is the import? Build config. Could be the Gradle script. These guys contradicting with one another. I'll give it one more go. This is the typical demo effect. When something works just before, but it's not guaranteed to work on the stage. Oh, and it completely successful. So I guess it is that thing. So now I can push that app again on my device. Just to show you that it works. There's always this awkward silence while it's building, and hopefully it will end soon. Now I should show you my screen. Now you see the app relaunches. There's some delay here. And I'll try to do the Bill Gates thing again. And it works. All right. So this is how you would code a demo. Just to recap a little bit, we have the tools, the HiAI Foundation tools to support you importing your own models. And then a lot of stuff happening behind the scene. But you don't have to remember everything. All you have to remember is in the end, you can call that model with one line of Java code. Of course, if you want to mess around with the C++ layer to put more efficient stuff in there, you can still do that. And If you want to use our trained model, you can use it through our HiAI Engine APIs, and which we also have a tool here. You can still do the drag and drop, and all the documentations are there, and it's just couple lines of code that would actually help you to leverage one of these nice models we have trained behind the scenes. So the one last thing I want to show you is the remote device. If the network is good enough here. Oh, I have to log in. Let's see. I'm tied to the Chinese version, but the one you have would be a European version. So don't worry that if you don't read Chinese, you won't have to take a 2-year Chinese lesson to be able to use our tool. And now, you see the device list. You can search here, of course. I want to just use one of these P20 devices. Okay, yeah. I saw the search didn't work, but it worked. So we have 3. If I kill this guy, we have more. Yeah. So I'll just use one of these P20s. I'll just click connect. Like I said, I didn't really have enough time to prepare the European version. So my version is tied to the Chinese version. So it actually right now try to connect to the lab in China. As you can see, there are some delays. Plus the network here isn't really great. But anyways, like I said, it's the Chinese lab, so it's Chinese. But the one you'll be using will be tied to the European lab, and you won't have to endure yourself with all these weird characters that you don't read. Like I said, it's from far away, so there's some delay here. Something is blocking this guy. Okay, now it's good. Then, of course, we can click all these buttons. So basically to interact with it. And I believe if I do the debugging, it's because this guy is lagging a little bit. Otherwise, I would have seen like 2 devices. But anyhow, this would be how you use our device remotely through our tooling. In case your dev team has more people than the amount of device you have, and all of a sudden you need to use the devices at the same time. Another thing I just want to show you briefly, which will be the last thing, it is this support we have here on the HiKey devices. I don't have one with me today. Otherwise, if I have plugged in, we'll say connect and installing the driver for me, and we'll project a virtual screen on my desktop. Or you can also connect that device through HDMI to another real screen. It's your choice. But we also support that in our IDE. And there'll be more testing services coming to Europe, and you can directly access that from our menu here. And that should be everything I want to talk about today. Thank you. And with that, I think we still have some time, right? If there's any questions, or yeah, please.
Regarding to your slides, the first one of the slides, there was this.
The first one and second one.
Yes, the first around the table with the different operators.
Yes, this one. Yeah.
So what exactly does this compare, and how does it make a difference in terms of sort of fitness, sort of,
I didn't quite get the second part clear. Can you use the mic? So you said about all these operators on the list.
Yeah, how do you compare them? What's the key metric to, or what's what's the
what's it all about? What does it compare? What is it possible to, you know, compare these operators? I mean, like, they're capable. Like you said, the Apple had like 60 operators, and
Yeah.
the Google had 30.
Yeah.
And so, what does it say in terms of, you know, might or some power of the frameworks?
Well, it's rather not about the power. It's just about your model, because you know different scenarios requires different kind of neural networks architectures and hence different operators to be used. For example, if you would train any sort of neural network on images, chances are you're gonna have to use convolutions. I'm not gonna walk you through the details of convolutions, but it basically does matrix multiplications and adding the results together. And in other cases, you would use, for example, ReLUs. These are one of the must if you need an activation layer. You use a ReLU or 10H or if it's binary classification, yes or no. If it's multiple classifications, if you want to tell images, if it's a chair or table or speakerphone or glass, you would use the softmax operators. So point being that for different architectures, you need different operators. For different scenarios, you need different operators. So it rather depends on your scenario and your architecture. It does not necessarily say that one operator is good or better or worse than the other one. It just, in different scenarios, you use different ones. I don't know if that answers your question clearer.
We have another one.
So I have maybe 3 questions. The first one is...
Oh, you have 3 questions?
Yeah, but
Good.
they are interrelated.
I think we still have time, right? Okay.
So the first question, do I have to be online when I create my own model in TensorFlow, for example, do I have to be online to convert this model to use it in Android Studio? Because you showed us the conversion process.
Okay.
And we use DevEco. Do I have to be online, or is it made offline?
Yeah. So the question is, in case the rest of the guys didn't hear it clearly, so the model conversion part, does it have to be online or offline? We have 2 solutions. One is that the conversion is done on your desktop. For this, you need actually to install Docker and Docker images, which I believe everybody knows how to do today, and everybody should have Docker Engine on your device, on your desktop. So if you have Docker, it's offline. It doesn't need any internet. Of course, you have to download the Docker image beforehand. But while you're converting, it's an entirely offline solution. And we also have the online solution, which will come, I think, next month, for those guys who doesn't want to install Docker or who somehow is limited with their choices and cannot install Docker. For example, if your laptop is managed by your company, or these enterprise managed laptops, you don't have a lot of freedom, turn on the virtualization engine to install Docker. So the answer being that there is offline version, there's an online version. Both are free of your choice.
Okay, thank you. So the next question is, maybe I will ask all the questions. What if my model isn't compatible with NPU? And the third question is, we have the operators for specific frameworks. I can see that the most operators are from TensorFlow. So does it mean that I should use TensorFlow for preparing my models because there is more operators, so there is a greater chance that my model will be faster when I prepare it in TensorFlow, not in Caffeine or Android NL.
Yeah, so the second question, I just want to repeat it, is that what if the operators is not supported, right? So the third question is that, okay, there are clearly, or apparently, more TensorFlow operators we support here, and a little bit more than Caffe. So does that mean we endorse TensorFlow versus Caffe? So to answer your second question, which is a really good question, by the way, if your model is not supported, because I actually forgot to demo one thing, because I only demoed you the positive case. As we know, in software testing, you always have to test the negative cases. Here, if I have a model that's not supported, I just want to show you how it looks like. This is a very complex model, a lot of layers. We use it for testing. By the way, this is the one the one that was successful with the AgeNet. It was a Caffe model, and here is a TensorFlow model for actually predicting human poses, like whether you're poses like this or like that, basically. And if you had run this guy, we'll go through the model checking part. Will actually tell me, oh, I'm sorry, it's not. There are some things that's not supported here, some operators that's not supported here, and I can click this guy to open the report. This guy, like I said, is huge. It has 248 layers. Normally, you wouldn't train such a huge model, especially when you are running something on the device. You wouldn't want a huge model, even though it's energy efficient. But still, you want to be constrained on the device rather than in the cloud. You can have a lot more computation power. And here we'll tell you that okay, these are the operators that's not supported, and reason being some of them it just we don't support this type. Some of them is that somehow you use you are out of the constraints. So once you see these kind of operators, you actually have almost always one choice left. You need to go back to actually go back to the training code to fix your model architecture. In some cases, you can replace one operator with another. Some cases, you can go work around. But that more or less means you have to retrain your model, unfortunately. And that might take from somewhere to minutes to hours, hopefully not days. Depends on how complex your model is. But with the current solution, when you hit a wall like this, you have to retrain your model. But we have actually a newer version, which is under development. Hopefully, it will come out pretty soon, like within a month or two, where you don't have to do this, because for those operators we don't support on the NPU, we actually have a CPU version of that, meaning that for these layers, we support it, but the computation is going to be offloaded to CPU, which means that it's going to be a little bit slower or less efficient than the NPU, but only for that particular operator or that particular layer. So if you don't have a lot of these layers or operators that's not rather compatible on the NPU, you are actually fine. For example, if you have 1 or 2 layers out of 10-ish, 20-ish, even 30-ish, basically that's fine. We just do the computation on the CPU. It's going to be a little bit slower. So maybe like half milliseconds or 0.1, 0.2 milliseconds slower, but wouldn't be like 1 second slower. So that's the solution there. Now the third question, if I still remember that, is we have more operators supported in TensorFlow and less on Caffe. Does that mean we endorse TensorFlow versus Caffe? The answer is no. It just happens so that right now we have a little bit more operator support on TensorFlow than Caffe, but we will quickly just to navigate around that and just have more operators supported, and you wouldn't have to see a list where Caffe is a bit less than TensorFlow. And you are, of course, always free to choose your own framework to train your model and to import your model into our framework. And we will support actually more kind of model formats. And for example, CoreML, like I said, will come out from, I think, in a month. So you can basically drag and drop a Core model into our tool, and we'll just convert that for you. And we are eventually going to support Onyx. For those of you who don't know about Onyx, it's kind of like, Onyx stands for Open Neural Network Exchange. Basically, it's a middle format that's compatible with everybody. Hopefully, every framework will build their adapters in and out of Onyx so that eventually we can support everything and hopefully all the operators. So that's the plan there. And also, a lot of times, forgive me for like maybe 1 minute's delay, a lot of times that's not, as app developers, we probably cannot dictate what our AI team or data scientists do. Sometimes they are just familiar with Caffe, then more than TensorFlow, and sometimes they just want to use TensorFlow, not Caffe. So normally your AI team or your model training team wouldn't be dictated by your request, and that's why we don't want to have certain endorsement to close door to one versus another. We want to support everything within our capabilities. But of course, sometimes there are just priorities. Caffe comes first or TensorFlow comes first. We might have to sacrifice a little bit and do that short-term, pick. But in long term, we want to support everything.
Maybe we still have time for a couple of questions. There was no one here, right?
There's one question over there.
Hello, I have a little question about your binaries. As far as I understand, you provide pre-compiled binaries, and it cannot be compiled with another C++, for example, application. Do I have opportunity to compile my own binaries for your SDK? Because, for instance, I need maybe a binary with Clang or GCC. Is it possible?
I don't know the answer of that question, unfortunately. But if you give me your contact information, I can relate to the right guy.
Okay, thank you.
Yeah, because I don't know a lot about Unity, and I don't want to speculate here. I'm sorry for that, but I'll come to you later.
Thank you.
Yeah.
So maybe we have time for the last question, if still one? Go.
Hey, so I have several questions. I'm not sure if we have time for all of them. I might have asked this yesterday as well. Does your API work on any NPU-powered device or only Huawei NPU-powered devices?
The answer is, at the moment, it works only on Huawei NPU devices.
Okay.
Because we are still at a very early stage of the neural processors on the device especially. So there isn't an industry standard there to guide everybody. So right now, we are doing our own implementation. I don't think any other device makers are doing it yet, but they will do it, just a matter of time. I believe a lot of guys will follow within this year or next year. But their solution might be for example, like Qualcomm, they have a GPU plus DSP, solution, rather than just an NPU, which is, if you ask me, less efficient and inferior, but that's her choice. So short answer being that it will only run on our devices. But we are working on a solution so that you can code your app once, and it runs differently on our device and non-Huawei device. So you don't have to code two apps. It's just one app that runs on all devices, but one is Huawei device. It just happens so that it's much more efficient. It does the computation much faster, so you will have a much better user experience. And other devices, you might have to face the choice of either let your user bearing the slowness or less performance app, or just maybe don't provide that capability on other devices. Have some sort of smooth transition out of that capability.
Okay, cool.
Yeah.
Thanks.